Hi guys. All right, here we go. Day 4, independent and dependent events. We'll start out a little practice from yesterday to make sure you know what you're doing. So the first thing we had to do was add up the numbers. So I added up going horizontally and vertically, and I wound up with my total of 510. So you guys go ahead and can do that as well. And then we'll try this just review question from yesterday. So the table below shows the results of a survey in which young adults ages 18 to 24 were asked if they ever used InstaShop, yes or no. Use the table to answer the questions. Okay, so you can see we're comparing two different apps and then gender. Find the probability that a randomly selected young adult who is female has used InstaShop. All right, so this is like a tricky conditional because the word given isn't there. But look, find the probability that a random selected young adult who is female, so that's the condition, has used InstaShop. So that's why we have to write it like this. Probability of InstaShop given female. Female is the condition. So I wanted to show you a harder conditional question. And then this one does say indicate whether or not it's conditional. So we can cross off choices 3 and 4 because they say not a conditional, and this definitely is. Okay, so you can pause it here and you do the math and then see which answer you pick. Okay, so hopefully you changed it to probability of Insta and female divided by, remember, probability of female. So 216 over 510 divided by 270 over 510. Top bottom. And you're left with well, I'll just do it. Keep the top. Multiply by the reciprocal of the bottom. These guys wipe out, which is nice to see every time. And we're left with this guy. And then we need to turn that into a percentage. So convert, in your calculator, and we do wind up with 80%. All right, so that was a little review from yesterday. Okay, today. Oh, again, I wish I was there with you because I had a little link here, and we were gonna play a little game, and I was gonna have you come up to the board, but we can't do that now. Okay, so let's see. Independent and dependent events. So what we're gonna look at today is whether events can affect each other's outcome. So let's take a look. It says, let's look at this first one here. It says the occurrence of one event could change the probability of another event. When this happens, we say that they are dependent on each other. So if they affect each other, they're dependent on each other. When the occurrence of one event has no effect on the probability of the other one, then we say that they're independent events. So what I did is I came up with just silly little examples here to try and make you understand, how events would affect each other or not. Okay, so let's take a look. So it says Grayson spins a spinner. At the same exact time, Kelly rolls a die. Are these independent or dependent? So do they affect each other? So the answer is no. They don't have any effect. Him spinning and her rolling doesn't do anything. What about number 2? Vicky picks a marble at random, and then she puts it back, and now she picks another one. Aren't those also independent? They're not affecting each other at all. It's the same sample space. During a card game, Ella picks a card, looks at it, and returns it to the deck. Next, Jeanette picks a card from the same exact deck. Are these two independent or dependent? Well, same thing. The sample space is the same, so they're independent. They're not affecting each other. But now let's look at 4. Anthony picks a marble at random. Without putting the first marble back, he picks a second marble. Well, now these are dependent, and these are like the questions we did on that first day, right? Where without replacement, you're affecting the sample space, so they are dependent on each other. What he gets the second time definitely depends on what he took out the first time. All right, and then I like this because I think this makes you understand too. It says, Mandy has a variety of socks in her laundry basket. Without looking, she selects one sock and then a second sock. So these are definitely dependent because that first sock changes the sample space of picking the second one. And then this one will probably be the one that you understand, I think, probably the most. Eve and Chantel pick chairs at the same dinner table. Eve picks first, then Chantel goes second. Definitely dependent. Eve got the best chair, right? Now Chantel can't pick that one. So they definitely are dependent. The sample space is changed. Okay. All right, guys. So we have a formula that we're going to use to test if the probabilities are independent or dependent of each other. So here's the formula. But I'm going to make it easy. I'm going to show you how to do it, so don't worry. Maybe you're going to have to watch the video, twice, or maybe you have to pause, and rewind and listen to me say it again. But remember, reach out to me on Remind, and we'll figure this out together, how to get you to learn this, okay? All right, so it says the idea of independence is one that comes fairly naturally, but sometimes we might not be able to tell, so a test is needed. So it says two events, A and B, are defined to be independent if. Okay, so if this is a true sentence, if the conditional, right, this is the conditional, is equal to the probability of the first one, then we say that they're independent. And the way I like to think of it is it's every other. Look, A, B, A. Or it could be B, A, B. It's just every other. Whatever you start with, you're going every other. All right, so I'm going to show you how to do this. You're going to totally get it. I'm starting out with a chart, though, with salt and pepper, and we need to fill in the totals. And this is a good question. It says 100 recipes in a cookbook that called for seasoning were compared. The use of salt and pepper recorded. It says, does a recipe calling for pepper depend on it calling for salt? So in other words, are they independent or dependent? So I don't know. I mean, could you guess what you think they might be? Anyone who cooks, usually things call for salt and pepper. So I'm going to probably say that they're dependent on each other, but, it doesn't mean that they are. Okay, so let's see. So this total is 72, and you have 58 so far, right? So wouldn't there be 14 more needed there? Right here, we could just add these guys up and get 28. We can add going this way and get 70. We can add going this way and get 30. And then I'll just get rid of all those arrows, okay? And then my most important piece is my total. Okay, so what's nice about the independent-dependent is order doesn't matter. Like, it doesn't matter, just watch first, okay? You don't have to write this part. So if I want to know when salt and pepper are dependent, it doesn't matter if I set up this probability of salt given pepper, but if I choose to write this, then it has to be set equal to the probability of salt, every other, SPS. I can use this one, or, and don't write anything because I'm going to erase this, or I can do probability of pepper given salt. And what would I set that one equal to? If I choose to use this one, it has to be every other. PSP. So it does not matter which one of those you choose. When you're doing independent-dependent, it does not matter. What matters is, though, you go every other. SPS. Or if you choose this one, PSP. Okay, so it doesn't matter which one you choose. But for today's lesson, let's just all choose the same one. And you'll see, because we don't really care what the number is. The number at the end isn't our answer. The word independent or dependent is our answer. But all your work has to be there. Like, you can't just say independent or dependent and be like, oh, I got it right. Like, all the work has to support it, obviously. Okay, so I want to know if salt and pepper are independent. So I'm going to choose to do probability of pepper given salt. But what am I going to set that equal to? Probability of pepper. So if the probability of pepper given salt is the same exact probability as just pepper, then I know that these two guys are going to be the same. So they'll be independent. And if they come out to be different, different, then they're dependent. So this includes yesterday's lesson. I change over the conditional to the probability of probability of pepper and salt divided by the probability of salt, and then we're setting it equal still to the probability of pepper. So it includes yesterday's lesson. So the probability of pepper and salt. So pepper and salt is right here. So that's 58 out of my total, which is the 100. What's the probability of salt? Probability of salt is 72 out of 100. And then we're setting that equal to the probability of pepper. So the probability of pepper is 70 out of 100. And now, guys, here's the nice thing. Are you ready? This is what we want to do. We want to compare two numbers. So you're going to do your top bottom on the left-hand side. So do your top bottom. And then turn it into a decimal, which is 0.805. Turn the right-hand side into a decimal, and you're just going to compare the two decimals. So are they the same or are they different? These two do not equal each other. These two are different, and then we use the symbol. See these three dots? The three dots stand for therefore. These are different, therefore dependent. It's easy to memorize D, D. If they're different, they're dependent. So salt and pepper are dependent on each other in this recipe. That's what they're concluding about all these different recipes. So this is your answer right here. They're different, therefore dependent. But what work would we be looking for? All of this. We would be looking for those calculations. Alrighty, so hopefully that's good. You're gonna see the pattern. We're just gonna keep going on this and practice. If the decimals came out to be the same, then we would say that they're independent. But you have to memorize that we're going to use this formula. So we use the conditional formula from yesterday when we decide if events are independent or dependent events. So those are going to be the words that you're going to look for. Okay, let's try another one. So it says a survey of 57 sixth graders was done to determine which subject was their favorite. The results are shown in the table below, sorted by gender. So again, we're looking at gender and subject. Does it appear, based on the data in the table, that the preference for math as a favorite subject has dependence on a student's gender? So we know right away we're going to be using, I think I'm just going to, if I was in class right now, I would have these formulas on the board and we'd be staring at them. So I'm just going to put it up here. Remember, this is the formula that we're going to use to decide if something is independent or dependent. It's probability of A given B, and you set it equal to probability of A. Those first two guys, right? A, B, B, A. Okay, it's every other. Okay, so we're comparing math and gender. So it doesn't matter if you do probability of math given gender or gender given math. It does not matter. And you have to pick a gender. You have to pick male or female. So it doesn't matter if you pick male or you pick female. But for purposes of us doing the same exact calculation right now, let's just all pick the same thing. So I would have had somebody just volunteer and give me something, but we can't do that, so I'll just pick. Okay, so let's do the probability of math, and I'll do given female. Okay, now if I choose that, look at your formula up top. If I choose to do math given female, what am I setting it equal to? The probability of math. Okay, yesterday's lesson, change this over. Probability of math and female divided by the probability of female and set it equal to the probability of math. Okay, I'm going to come over to the side and do the work, okay? So for this right here, I'm going to do it in red over here. So math and female, so 8 out of 57, right? Math and female, divided by the probability of female. So female altogether is 30. And then I'm going to set it equal to the probability of math. So 18 out of 57. And then just like we did on the last one, do your top bottom, turn it into a decimal. You're going to get 0.266. Turn 18 out of 57 into a decimal. And now compare them. What do you think? Well, again, they look like they're different. They're not equal to each other. So what would you say for this as your answer? You would say, oh, come on, work. Ay, ay, ay. Oh, my goodness. Okay, so you would say different, therefore dependent. And that would be your answer, and we would be looking for those decimals. Okay, so they're dependent on each other, according to the survey. What subject you like based on what gender you are. All right, let's do another one. Now we're going to do another one based off, I think, the same chart. So it says, does it appear based on the data in this chart that the preference for social studies, excuse me 1 second. Social studies has a favorite subject, has dependence on gender. Show the analysis and explain your findings. Ay, ay, ay. Okay, so again, I would have had you guys just come up with whatever you wanted to use. It doesn't matter if I go social studies given male, social studies given female, or if I put the gender first, it doesn't matter. But I'll just pick one and we'll all do it together. So let's do probability of social studies given male. Now, if I pick that, I have to set it equal to the probability of social studies. Yesterday's lesson, let's change it over. So social studies and math divided by the probability of, not math, male, sorry. And set it equal to the probability of social studies. Make a little room. Okay, so here we have 9 out of 57 divided by 27 out of 57. And then set that equal to the probability of social studies, which is 19 out of 57. Top, bottom, turn it into a decimal. Oh, actually, you know what? When we top bottom that, actually, let me do it. I don't have my where's my calculator? All right, hold on, I gotta do that. Let me just check the calculations on that 1 second. All right, so social studies and male. Social studies and male is 9 out of 57. That's good. Probability of male, 27 out of 57. That's good. And probability of social studies, 19 out of 57. Okay, so let's do it. So 9 divided by 27. Okay, we get 0.33, right, repeating. And then 19 divided by 57, we get 0.33 repeating. Okay, so here we do wind up with the same. Therefore, these events will be independent of each other. Okay, so if they come out to be different, they're dependent. They come out to be the same, they're independent. Okay, 9. So 9 I would like you guys to try, but I set up, which one I want us to use. So let's read it. It says, given the table on gender and sports preference are being female and preferring soccer independent events, justify your answer. Okay, so we could set this up obviously in many ways, with female going first, soccer going second, or vice versa. But just so you can try doing the calculations and follow mine, let's have you set up probability of female given soccer, and then we're going to set that equal to the probability of female. All right, you guys go ahead and give that a shot. Okay, so I changed it over, probability of female and soccer, right, using the conditional divided by soccer. Set it equal to the probability of female. Calculate each one. We should have got 0.6 equals 0.6. So we got the same, therefore independent. All right, hopefully you guys got that right. Rewatch the video, pause, try again. Homework is going to be, if you turn the page there, we're going to skip number 10. Homework is going to be day 4. And again, in the material section, if you print this, you'll have a copy of that. And then here's all the worked out problems for you. And then I think I was just putting a little review stuff on here if anybody wanted to do that, but you don't have to. Okay, you only have to do 1, 2, 3. All right, guys, have a good day. Bye.